Let's talk about how to simplify or write a rational expression in lowest terms. So first thing that you need to do is completely factor both the numerator, which remember is the top, and the denominator, which is the bottom of the rational expression. And remember, rational expressions are just fractions on steroids. Essentially, it's a polynomial over a polynomial. So you have a fraction with variables in top and bottom. In step 2, we're going to simplify or cancel out, depending on who you talk to, factors common to both the numerator, again, the top, and the denominator, which is the bottom. So essentially, if it shows up in top and bottom, we can get rid of it. Now, keep that in mind when we look at example number 2. Most students' first instinct is to go 3y cubed, yay, both of those go away. Not the case. You need to factor the top and the bottom. We can only simplify out or cancel out factors that show up in top and bottom. The same term shows up in top and bottom, but they are not factors. There's only one term in the numerator, so I'm going to leave that alone. In the denominator, I have 6y to the 4th minus 3y cubed. There's a GCF hiding here. The smallest number is 3, and that goes into 6. I have a y in both terms, which means I get to take a y out. And I'm going to take a y to the lowest exponent, which is 3. So I'm going to factor out a 3y cubed. And I'm dividing each of these by 3y cubed to take out the GCF. 6 divided by 3 gets me 2. Y to the 4th all over y cubed is y. Bring down my minus. 3 divided by 3 is 1. And y cubed over y cubed cancels out. They're the same. Now notice that I have 3y cubed up top and in the bottom. Now it's multiplied by something instead of being added or subtracted. So we can cancel the 3y cubed in top and bottom. Our answer is not going to be 2y minus 1 because the denominator is like mathematical Vegas. What happens in the denominator stays in the denominator. So that 2y minus 1 needs to stay in the bottom. We canceled everything out. We did 3y cubed and 3y cubed. 3 divided by 3 gets us 1, so we have a placeholder of 1 in the numerator. One way that I teach my students to remember why it's not okay to get the 3y cubed canceling out in the very, very first way that I showed you. Whenever you have adding or subtracting, it's like those two terms are combined. They're together. They're in a relationship. However, when you're not added or subtracted, you're single. So up top in the numerator, this guy is single. He's by himself. In the bottom, that subtraction means in a relationship. Now, if he tries to go out acting like he's single when he's in a relationship, that's a big red flag. No. Completely illegal. Okay? It's not okay to act like you're single when you're in a relationship. You can't do it. Here, when we did simplify in example number 2, notice that the 3y cubed in the denominator was out in front of the parentheses. He was no longer added or subtracted, meaning that he's single. And if he's single, he can go out and act like he's single. But in this example, remember, don't do this. Okay? I know it's tempting, but don't do it. Now let's look at a couple more examples. We have 5 plus x all over x plus 5. Now we've just talked about how we can't just get rid of the x's. No, because there's addition, subtraction, or here just addition, meaning they're in a relationship. They can't go out acting like they're single. But notice that 5 plus x can be rewritten as x plus 5. So Tom plus Judy is the same thing as Judy and Tom. And here you can notice that the x plus 5 shows up in top and bottom. We could technically say that they're in a group. We just don't normally write the parentheses when we don't have to. That's extra work. But if you notice here, x plus 5 shows up top and bottom, which means that they can reduce. Here, they're not acting like they're single, they're going out as a couple. And this is going to reduce to 1 because same way we did 3 divided by 3 is 1, x plus 5 divided by x plus 5 gets us 1. Let's try the next one. We have 5 minus x all over x minus 5. Let's say I try to do the same trick that I did in the last one, and I rewrite it with my x first in my numerator, so in descending order. Here, I need to be careful because it's negative x. There's a negative in front of the x. I got to keep it. Can't change anybody's signs. Plus 5, because my 5 is positive in the numerator, all over x minus 5. Now, x minus 5 and negative x plus 5 are not the same, so we can't cancel it out like we did in the last example. But it's like they're right there. It's so close, but the signs are off. When the signs are off, what we're going to do is factor out a negative 1 where the x is negative. If we factor out a negative 1, negative x all over negative 1, and a positive 5 all over negative 1, let's see what happens. Negative x divided by negative 1 gets us a positive x. Positive 5 divided by negative 1 gets us a negative 5. So by factoring out a negative 1 in the numerator, we now have negative 1 times x minus 5 all over x minus 5. And our x minus 5 is good to go out as a couple. And we are left with negative 1 as our answer. Let's look at one slightly more complicated. Here we have 3x squared plus 6 all over x cubed minus 3x squared plus 2x minus 6. Oh my goodness. So what we're going to do is exactly what the steps told us to do. We need to factor the numerator, factor the denominator, and see what we can cancel out. So let's look at that numerator. We had 3x squared plus 6. First thing we need to do whenever we're factoring is look for GCF, which in this case is going to be 3. We're not going to include an x because the 6 doesn't have one, but we can factor out a 3, and if we factor that 3 out by dividing, 3x squared divided by 3 gets us x squared, plus 6 divided by 3 gets us 2. And our GCF goes out front of our parentheses. Because we have an x squared, we should be checking to see if that parenthesis can factor further, but since I have an x squared plus 2 with no middle term, no linear term, this guy's not going to factor any further. So let's check out the denominator. I have x cubed minus 3x squared plus 2x minus 6. We have 4 terms, and whenever you have 4 terms, remember that means that you need to try factor by grouping. So I'm going to break it up into the left side, right side. Left side, I have x cubed minus 3x squared. I'm not going to have a number in my GCF, but I will have an x because both terms have an x, and they both have an x squared to give. So I'm going to factor out an x squared, which means, remember, I'm going to divide each of these terms by x squared, and the x squared goes out in front of the parentheses. X cubed divided by x squared gets me x. Bring down my minus. 3x squared all over x squared gets me 3. Let's go to the right-hand side. We have 2x minus 6. Here, my GCF, looking at my smallest number, is 2. 2 goes into itself and into 6, so our GCF is 2. Can't include an x because the 6 doesn't have one. Since my 2 is positive, I'm going to put plus 2 and open up my parentheses. 2x over 2 is x. Bring down my minus. 6 divided by 2 gets me 3. One last step on the denominator. Notice that x minus 3 shows up on both sides, which means that we can factor it out. So we get x minus 3 times what's left on the outsides, x squared plus 2. Now that we have factored the numerator, the top, and the denominator, the bottom, we're going to rewrite the original, but we're going to rewrite it in factored form. Okay, so up top, instead of 3x squared plus 6, we are going to say that we have 3 times x squared plus 2. In the denominator, instead of saying x cubed minus 3x squared plus 2x minus 6, we're going to say x minus 3 times x squared plus 2. And now, because everything is factored, we can go ahead and simplify or cancel out anything that shows up in top and bottom, which means that the x squared plus 2's are gone. If I rewrite this, I have 3 all over x minus 3. And when we think we're done, we always double check to make sure that we didn't miss anything. And you may be thinking, oh, crud, we missed a 3, which will get us 1 over x. No, where have you been? This is not okay. You can't act like you're single when you're not. You can't get rid of those 3's. That 3 in the bottom is in a relationship, so just leave it alone. Our answer is going to be 3 all over x minus 3.